Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at differentiation from first principles. Example 4 says differentiate the following from first principles. So the solution is the part A, we are given y equals 3x squared plus 2. What do we need to do here to guide us? We state the formula such that we work in accordance with the formula that says y dx equals the limit as h tends to 0 for the functions f of x plus h minus f of x over h. So from here we need f of x. For us to get f of x, we simply say let the function y be equal to f of x. Why? Because the function y is defined in terms of x. So we are saying that there is a function defined in terms of x. So therefore, the function defined in terms of x is 3x squared plus 2. We have f of x now. How can we get f of x plus h? Now therefore, to find f of x plus h, we simply use the function f of x. Where we find x, we substitute for it as x plus h. So in this case here we shall have 3x. Instead of x here, we shall write x plus h. But x is squared, so we square here plus 2. And then we expand either by operation of brackets, by Pascal's triangle, or by manual expansion. They give us the same answers, but we are using operation of brackets. So here we shall have 3 into, if we square this, we shall have x squared plus 2xh plus h squared. And then there we have plus 2. Let us open the bracket by multiplying all the terms by 3, giving us here 3x squared plus 6xh plus 3h squared plus 2. So now we have the expression for the function f of x plus h. So we can go now and use the formula. So therefore, or we can first get the difference outside before we substitute in the formula. So let's first get f of x plus h minus f of x. This term is the numerator in the function, so that we save the bulkiness of the work. So f of x plus h is here. It is 3x squared plus 6xh plus 3h squared plus 2 minus f of x. F of x is here. There are two terms. So since there are two terms, plot them together and say 3x squared plus 2. And then we simplify. If you open the bracket here, it means 3x squared here becomes negative. So it will cancel with positive 3x squared. If you open the bracket here, this 2 here becomes negative. So negative 2 here will cancel with positive 2. After that, we shall be left with 6xh plus 3h squared plus 2. No, we have used these two already. So we are left with two terms, 6xh plus 3h squared. So from there, what do? We now substitute in the formula. Therefore, dy dx equals the limit as h tends to 0 for the function. Now the difference is what we put there, because here they're saying subtract the two functions. So we have subtracted them and we have 6xh plus 3h squared over, the formula says, over h. What do we do there? we divide all the terms by the denominator h. And that gives us limit as x tends to 0. If we divide, we shall have 6x plus 3h. Shall have 6x plus 3h. Now, after dividing by h, then we turn h to 0. So as h tends to 0, we shall have divide x being equal to 6x plus 3 times h, which we are saying now h is 0. If we are turning h to 0, it means h is 0. This here now gives us here 6x. And that is the answer when we are differentiating the first equation, the first function from first principles. Now, if you want to be sure that you are correct, do a check. Quickly check. You have the function y as 3x squared plus 2. What is dy dx? When you use the knowledge of powers and coefficients, it's simply the same as 3 times 2 x squared minus 1 plus 0. 2 is a constant. If you differentiate the constant, you get 0. This gives us here 6x power 1, that is the same as 6x. So this is the solution to part A.